Okay, welcome everyone. I hope the lunch was nice. And then my goal will be to keep you awake in this digestive hour. How am I going to do that? Well, we're going to discuss the road to Gradle 9. And let's see. So, what are we talking about today? Well, in order to do that, I'd like to get to know you a bit better. And so I've got a few build questions for you. Who thinks they have a long build? Okay. That means there are a couple hands that stayed low. That's good. Are we talking an hour and more? Yep. Like let's count everything. Okay, so still a couple hands. 30 minutes and more? Who's above 5? Okay, yeah, that makes sense. And who's below a minute? Ah, there you go. Something was said here. Caching might help there. Yeah, we'll see. Oh, sorry. Yeah, the comment is that you can get a build in less than a minute if it's fully cached. But in order to get the right cache hits, you need proper input and output declaration. And that might be a challenge at times, depending on what you have. And we'll see that it actually plays a role in the evolution that we're looking at for the moment. Yeah, so comment is on the whether you should use clean and what are the impacts of that. And yeah, it's complicated. Yeah, I mean, at some point, we'll see about potential solutions. So the comment was that you try to explain that clean is not needed, but people don't trust that because often they don't trust the tool. The good news is around Gradle, it's outside of the open source solution though. We have solutions for that. So maybe you'd be interested to drop by the booth and I could show you some data-driven information that would help convince your colleague if the word of mouth is not enough. But before instead of continuing down that path, let's continue with some of the questions. Who estimates that their build setup is complex? Oh, that's nice. So that means there are a couple clean builds out there. Cool. That's exciting. And the last one, which is the funniest one in a way. Who's happy to actually use a build tool? Yeah, there you go. Some love. A couple hands up. That's really good. So yeah, so build tools is that category of tools that we all have to use, but it's usually not the tool we love because who's a software engineer when he gets up at work and says, hey, today, you know what I'm going to do? I'm going to run builds. No, you'd rather be developing features, adding things to your product, delivering some improvements to that web application or other things like that. So yeah, so build tool is a challenging topic. So thank you all for being here today because we're going to focus on that challenging topic. If you like a challenge, you're in the right room. That's good. So let's see which build tool though. So who here is a Gradle user? Almost everyone. That's excellent. Maven? A couple of folks. So I guess most of these folks then fit in that category, both? Okay. Anyone that uses neither of those two tools? Yeah. Okay. Yeah, SBT is an alternative. Bazel, make, yeah, sure, if you do native. So yeah, so now that I've got an idea, I think I've got the right crowd. Most of you are Gradle users. You have either performance challenge, sometimes complexity challenge, but definitely you might be excited by what I'm going to present on the road to Gradle 9. So first of all, I'll focus on the performance aspect because at Gradle, we strongly believe that the performance of a build is a feature. And when I say performance, it was interesting to ask the questions about the build duration because there is no absolute. Your 1 hour build might actually be totally justified if it's running hundred thousands of tests for a number of platforms, and maybe you just have no choice, or it could actually be more than hours. If you run a small microservice that's only doing one single operation deployed serverless, then maybe effectively being below that minute is critical. But our belief is that the question is not, is your build fast? The question is your build as fast as it can be? And we really invest in giving you that, that benefit by improving the performance whenever we can. And we look at a basic thing, compilation, and how we've recently made compilation even faster than it used to be. And then some of the more advanced features that are coming towards Gradle 9, which is configuration cache and isolated projects. Then after that, we'll take another trip into build comprehensibility, because yes, Gradle being a build tool that uses DSLs, which are Turing complete programming language, you can actually make a total mess of your build. That's completely open to you. The good news is, if you've looked at large Maven builds, enterprise Maven builds, you can do that as well. Like, this is not a unique feature of Gradle, but you can also make it really clean. And Gradle provides you tools to do that, but you have to use them. And some of them, in terms of adoption and deployment in Gradle versions, to make sure that the whole community adopts them, are challenging. I'll explain some of those challenges. And this is more a message for the build authors, not necessarily the build users, that we're hoping to embark them on these evolutions. And then we'll see what kind of things we have in store for the future, with some exciting development and announcement that we made recently. So, but why am I on stage? Well, my name is Louis. I've been at Gradle since 2018. I worked on the dependency management side of things, did some things around JVM, toolchains, things like that. For a couple of years now, I lead what we call the support team, which is effectively the team looking at every single GitHub issue filed against Gradle and making sure they're valid, descriptive enough. So if you get rejected, it comes from my team. And if things get worked on, I guess in a way I was part of that flow, but some of the internal teams do that. And with my graying beard and hair, my main issue is that I've got a hard time staying out of management, even though I would very much like that. And the reason I'm here is because Gradle, as a company behind it, used to be called Gradleware a long time ago. And you see the evolution of the logo here. And since 2008, the main goal has been to improve developer productivity. We do that with the Gradle Build Tool, which is an Apache open source project. We are now beyond 40 million downloads a month. Let's be honest, this is partly due to ephemeral CI agents. I've got another talk on that is recorded and exists out there, which I consider to be a waste of resources, but still it's a vanity number that shows adoption of the project. And in order to be paid and be able to be here, we have a product, Develocity. The idea is to give you an integrated platform for developer productivity engineering. So this is really collecting all the data from your builds, giving you graphs, giving you ability to investigate failures, and performance acceleration. And we consider that platform to be a key enabler of developer productivity engineering, which is a practice abstracted from tools that we defend and promote through various efforts. And you can find, like, we have a YouTube channel where we do interviews with some of the biggest productivity teams out there in larger companies. Just to give you an idea, that's a build scan. So that's what you get when your build data is recorded and what you can navigate. I'll use at some point a build scan during the presentation to illustrate features, but this is of course part of the commercial offering. So have a look if you're interested. My talk will be on the open source side of things. And this concludes the non-practical part of the presentation. So let's take a look at performance as a feature. I told you we would start with faster compilation. Who's aware of compilation avoidance? Okay, so the idea of compilation avoidance, it's a critical idea to speed up a build, is why do something that's not needed? And so I've got two classes here, right? An application class and then some library class. Is it big enough? That might, okay, cool. And the thing I do as an engineer is the diff that we see in that utility class below. And I effectively change the internal implementation of the class. Should my app be recompiled? And of course, the right-hand side of the diagram gives you the answer, but the answer is no. because this change does not modify any kind of ABI, application binary interface. So my app doesn't need to be recompiled. It can still talk to the public definition and the public methods of that utility. And this is something that we have had in Gradle for a long while, because it was introduced in Gradle 3.4, February 2017, so that's 6 years ago. And it's definitely one of the things that really helped improve the performance of compilation. But the question is, can we do better? Can we go faster? And so here we look at a graph that we published as part of a blog post where we did a performance comparison with Bazel, because Bazel has that reputation of being extremely fast. And if you look at the differences between Gradle 8.1 and Gradle 8.3, you'll see that we recently, so we released Gradle 8.6 last week, so that's pretty new versions, but we again managed to grab some more performance. How did we do that? Well, compiler daemons. By analyzing the performance of the compilation, we realized that quite some time was spent simply spinning off the compiler daemon. And so instead of killing them every single time, we now keep them alive. The graph comparison says 8.3 because that's when we wrote the blog post. Unfortunately, Windows, open files, clean operations after that caused some issues, so we had to stabilize compiler daemons for Windows in 8.4. But effectively, since 8.4, just upgrade your project, you'll get that feature for free. And Kotlin and Scala have their own support, because there it's the plugins themselves. The Kotlin compiler has a daemon, and for the Scala compiler, we delegate to Zinc, which also has a daemon mode, if you configure it that way. And so, as you can see, even though some of the important efforts in getting compilation to be fast were done years ago, we still managed to figure out new ways to speed up the process by, again, looking at what's happening under the hood, but also, let's be honest, being challenged by newcomers on the market. So there's another big difference in that graph, and that's between 8.0 and 8.1. What's up with that? Well, that's the configuration cache. So it's the ability for Gradle to effectively cache the whole configuration phase. You could ask, what is the configuration phase? So I've got a very small graph here. Bars are not to scale. But effectively, when you start a Gradle build, you run a JVM process. A number of JVMs needs to be started. Once that's done, we will parse your build logic, execute it. And only after the proper task graph has been created can we start executing your actions. And so what we see here in that blue color is, if you want, the overhead of the tool. So this is not work that you're waiting on. What you're waiting on is the result of the compilation, the result of the test, that archive to be produced, not what's happening during the configuration phase. But given the way Gradle is set up, we need to apply those plugins. We need to execute all your build logic. And most importantly, we need to compute that task graph. That means select and configure the tasks that will be run, and discover their dependencies and do the same, configure them so that they can be run. And what we do with the configuration cache is we effectively cache all of that work so that the only thing we have to do, if your inputs are the same, is to just restore the task graph and start working it in opposite order of dependence, right? Like you start with the tasks that have no dependencies, and that clears up tasks that depend on them. And then you move towards the ultimate goal of your invocation. There was a comment earlier that caching is efficient only if you have good input-output determinism, and that's effectively the complication of the configuration cache. You need to cache the setting script, all the build scripts, if you apply or not init scripts, system properties that are used by the build, Gradle properties, any configuration file that is, any file that is read at the configuration phase, environment variables, if you have custom build logic, build source, included build, and so the volume of what needs to be checked and cached is really the challenge, and which is why, in terms of focus, doing caching for tasks, like the execution cache, was more efficient, and we only looked at really doing that for the whole configuration phase now. So what are we caching? Well, the task graph, because we need to know what needs to run. The inputs to those tasks, because when we want to restore the whole model to just execute it. We do not want to restore the whole in-memory representation of the project, of the build, of what it contains. We just really want to focus on what's needed to execute as fast as possible. And so that means we discard all the rest. There is no project state. But because of that, it means there are requirements in getting the configuration cache to run. You cannot have any live JVM types as an input to a task. Now, when you look at those types, a class loader, an input-output stream, threads, these are usually not things you really need as an input to the task. And if you need something like a stream, then maybe it's just easier to point to a file and then let your task implementation transform that file into a stream upon execution. Another constraint, which is something that's effectively impacting the community and making the adoption of the configuration cache take a while, is you can't reference Gradle model types at runtime. But a couple years ago, the way you would reference some information from the project when your task runs was simply by having the project object and accessing it, because it was available, it was there. Why would you do it differently? And so with the configuration cache, in order to get the benefits, you have to rework build logic, and that means also that plugin authors often have to rework their community plugins in order to make them compatible. And that's clearly one of the biggest challenges. Yeah. Yeah, so as stated, it's one of the main blockers is the third-party plugins. File issues against them, convince them that it's useful. It's effectively a community effort. Yeah, it's a challenge given the volume of third-party dependencies. So just to give you an example of what is an invalid output and how you can make that compatible, let's say that you've got a custom task. That custom task takes a source set historically as an input because that's something you can grab from the project. And the thing you do is you ask for the files of the compile class path of that source set, which a couple of years ago was a perfectly valid way of accessing Gradle project state. Now, given that you cannot use anything that's related to project state, what you have to do is to move to just a file collection, a configurable file collection, in this case, as your input. Inside your task action, you just get the files from that file collection. So we effectively shorten what happens in the action. But when you configure the action, which is the line down there on the slide, what you do is at that time you say, hey, I'm going to take the source set compile class path, which happens to be a file collection, and say that my input to my task should be sourced from that same file collection. And so, of course, this is a simple example. And sometimes it's a bit more complex depending on the types and the information you need in your task. But it shows also that it can be done. So why does it matter? Well, first of all, your configuration time goes almost to zero. So you completely bypass that phase of the build upon successful load from the cache. And while the configuration phase, as usual, can vary a lot between different build setups, we know that the largest Android applications out there sometimes have configuration times that go into dozens of minutes. And so if you can save that, especially if you can save that on the local development cycle, it's really impacting the team. Also, there are more benefits than just skipping the configuration phase. Because what we're saying is that a build which has a valid configuration cache state gives actually stronger guarantees to Gradle about task isolation, because it means that the task no longer relies on the project status. If a task no longer relies on the project status, then it allows us to run the task faster. That's the first benefit, but also in parallel. So effectively enabling the configuration cache will turn on Gradle parallel transparently, like you no longer have the option to turn it off. But that parallelism goes one step further. It actually runs the task from a single project in parallel. Because in order to have that saved state, you must have this clean separation of concern. And it means there cannot be an ordering problem anymore between your tasks. They have to be cleanly modeled. They can't grab state from the other task, because you cannot reference a task from a task. That's again something that you cannot do, because when we deserialize, where would we get that reference? So let's quickly show what that means. Where am I? Yep. So what I've done is I've used the Gradle project, and yeah, the gray means also glasses when I look at my screen. I've looked at the Gradle project, and I've been running tests. Gradle itself is a pretty large build. And if we look at the first time I ran the test, it took me 2 minutes. 2 minutes for something that IntelliJ reports as a 600 millisecond execution. Like, that's a lot of overhead, effectively. So now the good news is, if I rerun that, it's much faster. It's still not instantaneous, because we still need to restore that configuration cache state. And maybe we should look into the Gradle build in order to make that configuration cache state leaner. But I still have a 600 millisecond execution, but this time my build was effectively only 10 seconds. The tasks that were executed are probably... We'll look at the build scan in a sec. It will tell us. So, of course, here what I'm doing is I'm doing no changes in my project, and I'm rerunning tests. I mean, aside from redoing the same things and expecting a different outcome, you won't get much through that. But the benefit here is that if I go anywhere in code and I just add let's do something like that. No. Come on. So I've effectively changed code. If I rerun my task, it won't have an impact. I'm not even sure that code is used. That's not what I'm trying to show. What I'm trying... I got my import, of course. Well, you know what? That still is a good example. It still failed in 4 seconds. So I still got my configuration cache hit. I was not waiting for the build logic to be recompiled, reconstructed, like the whole model of my project to be again set up just to tell me that I'd done a stupid mistake by importing something that shouldn't be imported because it's not accessible. So now I can rerun again. And interestingly enough, getting the configuration cache to work in Gradle was not the only part of the story. Remember, I told you that one of the inputs we need to account for is injection of init scripts. For the longest time, that was the strategy used by IntelliJ to run tests in Gradle. They would inject an init script that would configure which tests were needed to be run. But it meant that rerunning a task was always changing that init script, and so you would never get a configuration cache hit. But now, with recent IntelliJ releases, they moved to the proper APIs that we've offered them through the Drilling API, and that gives us configuration cache across the whole chain. And so once again, 500 milliseconds, we've reused the configuration cache. And 19 seconds, sure, but this time there was compilation. So that's why my build is slightly longer, because of course, even though I've got compilation avoidance and everything, I still needed to recompile some classes. So 10 executed is probably these compilation tasks, but let's take a look. So that's the build cache, the build scan, sorry. And what I can do is I can go into my timeline and I can look at all my success tasks. Where is my separator? And here we see all the tasks that effectively reported a successful execution. And so dependency management, compile Java, go away. Of course, I can look at the details. The task was not up to date. Input property, something changed. The class I modified, the file I modified. I guess it didn't like me resizing it. Okay, I'm sorry, I can't find the... and of course, test, which was the main thing I was executing my test. And that's because the whole point when you run tests from the IDE is we want to force rerun the tests. And so we never mark them up to date. And the benefit of what we looked at is that I can also change tests. So if I go run a different test in the same project, it still is the same invocation from the perspective of the configuration cache. The only thing that was changed is the test filter. And so once again, I'm hitting my configuration cache. Yes? Yeah. It's still doing what needs to be done, which is restoring the configuration cache state. No, but you still need to know what needs to run. So you still need to restore the task graph. And once you've restored the task graph, then you can start executing it. And then the execution, I mean, even if all the tasks are up to date and everything, it still takes a bit of time to validate, did the input change? No? Okay, moving on. Yeah, but we still need to run the test. Yeah, so that's what I'm saying. The configuration cache improves that overhead, but it doesn't make it disappear completely. And because Gradle is such a complex build with lots of build logic and a complex task graph, you still see some of that overhead. Let me go back to the slides. Okay. Where did my... There we go. Yay. So there are limitations, right? What if my work is a build engineer and I mostly modify my build scripts? What about tasks like doing a dependency upgrade, which software engineer might well do, you know? You start your work and you need a new version of a library in order to benefit from these new features. When you do that, what happens is that you're changing the build logic, you're effectively invalidating the configuration cache. And that's where project isolation comes in. So project isolation is effectively the next logical step for Gradle in order to keep improving performance and keep shrinking that overhead that we see at the beginning. Project isolation is really efficient when you have a cache miss, a configuration cache miss, because you need to run the configuration phase. And one thing that you have to know is that historically, that configuration phase in Gradle is very much single-threaded and completely sequential. So that means if you've got 1,000 projects, we will configure projects one after the other. And it comes from the fact that, again, historically, Gradle offers a completely mutable model that's reachable from pretty much everywhere. And so folks took the use of, hey, I'm in project B and I'm going to go grab project C and do something with it. Sometimes read-only, but oftentimes I'm also going to configure it a little bit more because I've got opinions on what it should do as a project. But if you do that, then you have to be linear because otherwise you can't have any guarantees in terms of execution. And so by strengthening guarantees further, we can actually do that configuration phase in parallel and also incrementally. Like effectively isolating the projects, hence the name, right? And have the ability to say, hey, 20 projects didn't change, I'm just going to load them from cache. Oh, 2 projects did change, let me configure those. And then even those in parallel. But like I said, it means more constraint. It's over. Not only can you not access the model of Gradle from the task execution in order to get the configuration cache. For isolated project, you actually cannot mutate project state as part of the configuration phase. And so we were discussing earlier on that it makes it a challenge in terms of adoption. We expect project isolation to also be a challenge in terms of adoption. The good news is we've learned. When we started the configuration cache experiment, it was pretty much an all or nothing flag. Like if there was a violation, you couldn't do anything. And then we managed to evolve that, and in the later version, right before it becomes stable, you could do things like, hey, my build is mostly configuration cache compatible. For example, I've optimized the development workflow, but there are still CI pipelines that need to run the configuration phase each and every time. And we take the exact same approach with project isolation. We're looking at giving you the ability to really adopt it gradually. Potentially getting the benefit of, hey, 10% of my projects can be configured in parallel. Okay, let's do those, and we'll do the rest sequentially after. However, this is clearly an alpha experiment for the moment. This is the next thing that we want to deliver. It's heavily worked on, so the changes in the nightlies can be observed. It's mostly interesting for early adopters or folks that have effectively that challenge of getting configuration cache miss and still having a very long execution time. And one of the things we're focusing at the start is speeding up the IDE experience. Because once again, in order for IntelliJ to understand my Gradle project, it needs to query the Gradle model and represent that according to the IDE model. And that step also effectively requires running a good section of the configuration phase. And so that's where we hope to have benefits, which then gives you the ability to effectively do a change in your build configuration and see it reflected in the IDE in a much shorter cycle. That's what I had in terms of performance. Any questions at this stage? Yes? Yes. Yep. Yep. Yes. Yes. So the question is about the usage of all project and sub-project as a way to apply common configuration and not have to repeat yourself. There are two things. So first of all, what we recommend and that you can use today is move all of that to convention plugins. And then what you repeat is the application of the convention plugins on all your projects. But it means that you effectively get almost the same benefit. I would argue that you get an even better benefit, which is the fact that you open any build file and you can see that a convention plugin is applied. You can navigate to that convention plugin and you can figure out what it does to your project. When this is done via an old project or a sub-project block and you open the build file, you have no idea about that relationship. And depending on the project complexity, it might be a challenge to figure that out if you're new to the team, or if it's an area of the code you're not familiar with, or if it's maybe not pure JVM world, but some other ecosystem. So that's one answer. The second answer is there still are good use cases for that. Like there are lots of plugins who in terms of application will tell you, hey, just apply me to the root project. I'll do the rest magically. And we recognize that's a valid use case. And we actually hope to have an incubating solution for that specific use case in Gradle 8.7. Of course, any kind of statement like that is subject to if it works or if it doesn't have to be delayed, right? But yeah, so it's another part. We know that there are valid use cases. And in terms of pure all project sub-projects, I highlighted mutates in that slide. The reason is that we're still considering that why would we completely cut off that API? We could effectively instrument it in a way that if the only thing you're doing is listing the projects, getting their names, getting their path, which effectively means you're accessing immutable information, then it's not a problem. Because this is information that's effectively known after the settings part of Gradle has been resolved. So that's, yeah. And there was another hand. So it was marked as stable in Gradle 8.1, and I'll explain what should happen to it in Gradle 9. Yes? Oh, sorry, the question was, is the configuration cache already available in Gradle 8? Yeah. So the question is, does it work automatically? No, it's currently marked as stable, but you still have to opt in. What we're looking at is making it the default for Gradle 9. Yeah. Yes? Yeah, so the question is, are there specific pitfalls with included builds and configuration caching? I know that right now for isolated projects, it's just a deal breaker, so it's not supported. For the configuration cache, the Gradle build itself uses included builds a lot for all the build logic, and it works. Things are moving so fast in that area. I don't remember a specific one, but like it's definitely been evolving, yes. But like in recent version, and definitely since 8.1, since it's stable, I would say there are no deal breaker there. Okay, let me continue. So, build comprehensibility. Here the idea is, that's all good, your build is fast, but if you can't figure out what it does, or if you can't evolve it, it's a problem. And the first thing I wanted to discuss is laziness as a solution. What do I mean by that? Well, Gradle is effectively executing a directed acyclic graph, a DAG, which the configuration phase creates. You have an example of a fake one, and then another one on the right-hand side, which shows a little bit the classical Java library project and the kind of dependency it has. Of course, that test dependency, as you can imagine, goes back into requiring the classes and the compilation of the production code, because how could you run your test if you don't compile your production code? So this is really a graph, and depending on the size of the project and depending on what kind of invocation you emit, we could be talking about tens of thousands of tasks in that graph. But Gradle figures out that graph by running code. And we all know that running code has a number of constraints. One of them is there is ordering in what you evaluate, right? We are not in a fully declarative model in terms of configuration where you could say, hey, I've parsed the whole file, I'm not gonna figure out what it means, and then you have no ordering problems. We're running code. An answer that existed for a long while in Gradle is after evaluate, where effectively you say to your build logic, hey, you need to run after everything else has run. And then comes someone else that says, oh, I need to run after that. And then someone says, I actually need to run in between that. Like, just like doesn't work. How after do you need to be is a really tough question. You also have the main exchange system between Gradle tasks is effectively file-based. Like a Gradle task has to produce a file, otherwise it cannot be cached, because it means we can't verify whether its output is still present. You can have tasks that don't do that, but then by definition, they're not cacheable, they cannot be up to date, and so they mean they will be executed each and every time. And when you do that kind of things, well, if you declare a file at the top of your build, and then use that as an input in a task, and then use that as an input, as an output in another task, how will Gradle figure out that that file is actually shared between those tasks, and it creates a dependency between them? And this is the kind of things that we saw, and Gradle had APIs for that, depends on, where you can explicitly declare your dependencies, but it means that if you mess it up, or if you don't realize what that line does and try to clean it up, you could break your build too easily. We even have examples in the documentation. So that's publication, and you're trying to get the archive base name of the jar task, But if you do that without thinking too hard, who knows? Maybe the jar task is not yet properly configured. And so the information you're getting is the default and not what you need. Solution is laziness, effectively delaying all of these decisions. So what we did was introduce quite some time ago the provider API, where you wire and derive values. And you don't care about when it is set, because the way this works is a task will only realize the value, like effectively query it for its value, when the task needs to be executed. And so that's the ultimate after evaluate. It's on demand. Because the provider API, we knew that that task dependency was an important concept. These properties keep information about what produced them. And so if a task produced a file, then depending on that output creates automatically a dependency in between the tasks. And like I said, evaluation is done on demand, which also means that if the task doesn't run, we don't compute inputs. So that's also a performance benefit. Because if a single task in your build needs to process a large file for whatever reason, well, the benefit you get is that if you do not run that task, you do not pay that price. So this is an example of the kind of things we're looking at. So we just register a random like producer, consumer tasks just to indicate their roles. And we can see that we don't care about the order of evaluation. We start with the consumer and we say that its input file is actually the output file of the producer. The flap map in between comes, of course, from functional construct. You've got a provider on the left-hand side. If you just map it to the output file, which is already a provider, you will end up with a provider of a provider. And so the flap map ensures that you're not nesting providers. Then we do the same for the producer, but here we actually say, hey, by the way, that location depends on the build directory. And then finally, we say, oh, in my build, I don't want to use build as the output directory. I'm going to use output. But because all of these properties are evaluated as late as possible, you will get, when you configure the consumer, that it needs to look into output /file.txt, and that by doing that, it must have a dependency on the producer. And so if you run the consumer, you must run the producer first. The provider API has two main types, provider and property. They're clearly modern Java types in that sense, meaning that since they wrap a value, you have all these map or else, get, or null, things like that. So quite functional in style. But there's an adoption challenge. The Gradle API is pretty large. Like what we have inside plugins, the number of core plugins we have, and even what we offer to build authors. That means lots of properties to convert. The strategy we used so far was an alternative properties introduced that uses the provider API, then we deprecate the original property, and then finally we remove it. But it's a disruptive cycle for the users. We have to do that per property. And it's a long cycle because, as you can see, the removal can only happen in a Gradle major version because that's a compatibility guarantee we give. And also, when you have to bridge the older APIs and the newer APIs, it's challenging. So in short, again, it does not scale. One example that we have recently is we deprecated build here. So again, the location where the build will write its output. And it used to be used like that. File, a string, I evaluate build here, and then I add something at the end. Well, that's completely eager. The moment you read that string, you evaluate build here. If you change it later, it's too late. It's been read with a different value. And you can do it with a new API, layout.build directory, where you can do .file and then specify the file. And then you know that that file would be relative to whatever build directory it's pointing at. But it's awkward because if you have to bridge it to the older APIs that only take a file, you need to do that get as file. Boom, you're eager again. Or you have to map it if you actually want it path. So it's not great. There are still benefits. We recently worked with the Kotlin team so that we now have an assignment operator. So for simpler configuration of the build logic, You used to have to do description.set. You can now do just description equals. So that's really good. And it means that we're looking at effectively doing a provider API migration and do that large scale for Gradle 9. What we hope to provide is support for plugins so that effectively when we know a plugin has been compiled against a given version of the Gradle API, we will have the ability to automatically redirect the properties to their provider API compliant version. And of course, it requires polishing the provider API itself. So it does not resolve the adoption by community plugins, but it helps, we hope, with general usage of that API and then plugins being able to jump on it, jump in on it. So a few more minutes to go. Modeling. That's an element that we realized has been a challenge. Gradle has an amazing execution model. Of course, I'm slightly subjective when saying that. I'll recognize it. But leveraging it requires expertise. Like it is sometimes really frustrating to try to do things and then realize they don't work and then figure out the right path to do it. And also, common use cases are not always easy to express. This used to be the documentation on adding an integration test system. We have to know about source sets. We have to understand how a source set is wired to the production code. We have to understand that there are inheritance hierarchies between the dependency configurations so that you get the right dependencies. And effectively, if you forget any of those lines in that slide, and the code still compiles, like, so I'm not talking about the curly braces, but like any instruction in there, you'll get a different kind of failures for your integration test. They don't run, they don't find the production code. This is what we've done with what we call the test suite plugin. Forget about all of that. Why you, as a build author or as an engineer that needs a new test suite, should you care about everything I told you about? Like it was plumbing. This is declarative. This is, hey, I need a new test suite. It's going to be my integration test. And by the way, I require the project sources. And that's it. And all of the wiring happens behind the scenes. There are more to that plugin, so take a look into the documentation. You can configure, and the kind of things we want to develop there is, for example, also the ability to say, by the way, I want all of these tests to run with different Java versions, different Gradle versions if I'm writing a Gradle plugin. All of that, again, declaratively. In the block here, I'm using implementation. If you know Gradle dependency management, you will know that this normally talks about a specific configuration for my production code. But what we do is actually, we are in the context of the integration test. So we're talking about the implementation of the integration test. We're effectively abstracting and contextualizing the dependencies block. And we actually believe that's a great idea in general. And so we want to introduce that block so that it can be reused in different contexts. Configuration names will remain the same, so you have to learn one set of configuration names and remember their roles, and then you know they apply based on the context you're in your build script. And it matches patterns for other ecosystems. So if we look at the Kotlin multi-platform example, they have exactly that. All of these implementations, these two implementations have actually a different meaning. But when you look at the build script, telling you that the first one applies to command main and telling you that the second one applies to iOS main is pretty easy to understand. That context, that's where we're good at. So, looks like I may have a hard time for questions. I'll be happy to take them at the end, outside. The last minute. Like I said, Gradle 9. One of the objectives is stable isolated projects. The other one that I mentioned, and I realize I forgot on the slide, is to have actually the configuration cache on by default. You would still be able to opt out, but it would be on by default. Provider API 1.0, that means we want to have a set of supported use cases and really finally flesh out that API. That then gives us the ability to do the provider API migration and associated tooling. And of course, bug fixes and improvements. We're talking Q3, Q4 this year. Again, tentative. That might change. Another quick snippet of information. We recently had a blog post about declarative Gradle. So there we actually want to even go further and separate the software definition. What is your build doing from the build logic? That uses a restricted DSL, exposing domain-specific concepts. And then we hope that it gives us a better user experience. That's it. And so I'll happily take questions outside.